All right, so in this video, we're going to talk about three more commonly used types of concentrations. So there are mass and volume percent concentrations. So there's three types because it depends on what you're doing. The first one is a mass percent. And that means that I'm going to dissolve a solid solvent, or excuse me, solute in a solid solvent, right? So I'm actually going to have a mass of some solute that I'm going to dissolve in another solid. So I'm not going to be able to measure the volume very easily, which means I'm just going to worry about what is my total mass when I combine those two things together to make this percent concentration. So if I take my grams of solute and divide by a total gram, and then I take that times 100, that's going to give me a percent, right? So this would be like if you were going to mix two different kinds of waxes together to make a candle or some chapstick or something like that, right? Otherwise, the next example, percent mass volume, this is the one that's halfway similar to a molarity because you'll have a solid that's dissolved in a liquid, possibly water, right? So in that case, I would talk about grams of that solute that are being dissolved. I divide that by my total volume of that solution. And then I take that times 100 and that gives me my percent. So it's similar to a molarity. The difference being I'm not talking about moles, which is actually a problem. This is not going to be as useful of a concentration because it doesn't have the moles in it already so that I can do mole relationships when things are reacting together. But it is simpler in terms of, okay, if I'm just going to dissolve 9 grams of salt in a liter of solution, I can very easily come up with my 0.9% concentration, right? So I don't have to do a whole lot of math. In this case, if I told you that you have a 5% solution mass volume, that literally just means you have 5 grams dissolved in 100 milliliters because that'd be the simplest calculation you could do, right? You actually kind of want to make that volume some power of 10 so that you don't need a calculator to do these things, right? But otherwise, I also have a volume percent that we need to have an equation for, and that's going to be milliliters in milliliters because it's kind of similar to that mass above. I have a milliliter of solute, right? So it was a liquid to begin with that I'm going to dissolve into another liquid, but there's going to be a total volume when it's all said and done, and that's going to affect our calculations at the end of the day. When I divide those things and then take it times 100, that'll give me my percent. So these are the equations that we use, but otherwise specific problems look kind of like this. So if I had 14 grams of beeswax mixed with enough paraffin to make a 125 gram candle, all I need to do to come up with a concentration here is take the mass of my solute, which is whichever mass is smaller. In this case, 14 is way smaller than 125. But remember, the paraffin was actually 111 grams in that context because the total mass of the candle is 125, right? So you have to be careful there. But 14, the beeswax is definitely my solute. I'm going to take that divided by the 125 grams total, take that times 100, and that'll give me a percent of 11.2. So I have an 11.2% concentration, right? Mass in this case. So it's 11.2% beeswax. The rest of it is paraffin, obviously. So I could look at it from that standpoint too. I could talk about how it's, what would it be, like 88.8% paraffin, but that's not necessarily useful, right? Usually you're going to talk about a percent that's less than 50 if it's going to be your solute that you're dealing with. Otherwise, if it's a mass volume, it would look more like this one, right? And this is asking me what mass of silver nitrate is needed to prepare 65 milliliters of a 20% mass volume aqueous solution. So this I'd actually set up a lot like it was a partial pressure problem from last chapter. I'd take my percent, which is 20, right? I would make that into a fraction personally. and then just set up a ratio on the other side that'll be grams over milliliters. I know my 65 milliliters. I just need to solve for x in this case. So that's how I would solve this. Otherwise, you can totally use the equation that was given to you before, but you'd still divide 100 over and then solve for x eventually anyway. So it always ends up looking like this. But just set up a ratio. 20 over 100 equals x over 65. If I solve for x, I'm going to get 13, right? So assuming I have two sig figs, which it said at 20%, with 20 only has one sig fig, so I'm going to have to round this. So I'm going to have a 10-gram mass of silver nitrate that I need to dissolve in this solution. So 10 grams, dissolve it so that there's 65 milliliters of solution, and you're going to have a 20% mass volume silver nitrate solution. So that's how I'd work that problem out. Otherwise, this is the one that's kind of tricky. So that total volume and or total mass from our mass or volume type calculations, this one's going to be a volume, is going to trick you sometimes. So I'm going to do the same thing here I did on that last one. I'm going to set up a ratio, 35 over 100 equals some amount over another amount. But it's telling me that I'm going to put water in I'm going to add water to 175 milliliters of alcohol to make a 35% aqueous solution. So that tells me from the get-go that alcohol is my solute. So, because it said aqueous. So 175 milliliters, that's going to be what I put on the top. Otherwise, the X that I have on the bottom is technically that volume, 175 milliliters, plus water, right? So I'm going to solve for X, but I got to be careful not to stop there, right? So if I solve for X in this case, right, multiplying and dividing, X is going to be 500 milliliters. And that would probably have two sig figs because of the 35%. But I have to remember that that's my total volume, right? That includes the alcohol. So I actually have to subtract the alcohol amount out of there. So I have to subtract 175 milliliters from that 500 to get my actual answer, which is going to be, what, 325? But then I have to round it because of my sig figs. So I'm going to end up with 330 milliliters. That's how much water I'm going to need to add to that alcohol to make this solution. So you always have to remember to subtract a part from your total to get the part that is your solvent, right? Again, water is the solvent because 330 milliliters is bigger than 175. But otherwise, you can flip that. Water will dissolve in alcohol just as easily as alcohol dissolves in water. So it could be a non-aqueous solution. But since it said aqueous, I know that that's how it was supposed to work.